Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Predictive Maintenance and Operations. Predictive maintenance and operations, when integrated with AI technologies, serve as a cornerstone for modernizing supply chain and operational management. Predictive maintenance refers to the use of data analysis tools and techniques to detect anomalies in your operation and possible defects in equipment and processes so that they can be addressed before they result in failure. The integration of AI into predictive maintenance enhances the ability to predict equipment failures, optimize maintenance schedules, and reduce operational downtime. This approach leverages machine learning algorithms, IoT devices, and big data analytics to create more efficient and reliable operational processes, thereby driving significant cost savings and improving overall productivity. One of the most compelling advantages of predictive maintenance is its ability to transform raw data into actionable insights. Machine learning algorithms can analyze vast amounts of data from various sensors installed on equipment to predict when a machine is likely to fail. For instance, General Electric uses its Predictive platform to collect data from industrial machines and predict failures before they happen. This capability not only minimizes downtime, but also extends the life of the equipment and reduces maintenance costs. A key component of predictive maintenance is the Internet of Things, which allows for the continuous monitoring of equipment and systems. IoT devices collect data on temperature, vibration, pressure, and other critical parameters. This data is then fed into machine learning models that can identify patterns and predict potential failures. According to a report by McKinsey, companies that implement IoT-based predictive maintenance can reduce maintenance costs by 10 to 40%, reduce equipment downtime by 50%, and extend the life of machinery by years. The role of AI in predictive maintenance extends beyond simple prediction. It involves optimizing maintenance schedules to ensure that interventions are carried out at the most opportune times. Traditional maintenance strategies often rely on fixed schedules or reactive approaches, which can be inefficient and costly. In contrast, AI-driven predictive maintenance uses real-time data to determine the optimal timing for maintenance activities. For example, a study conducted by Deloitte found that predictive maintenance can lead to a 30% reduction in maintenance costs and a 70% reduction in equipment breakdowns. Moreover, AI-based predictive maintenance systems can learn and adapt over time. As more data is collected and analyzed, the algorithms become more accurate in their predictions. This continuous improvement capability ensures that the predictive maintenance system remains effective even as operational conditions change. For instance, Rolls-Royce uses AI to monitor the performance of its aircraft engines. The system continuously learns from new data, improving its ability to predict when maintenance is needed and thereby ensuring the reliability of the engines. Another significant benefit of predictive maintenance is its impact on supply chain management. By reducing equipment downtime and extending the life of machinery, predictive maintenance ensures that production schedules are more reliable and efficient. This, in turn, leads to more predictable supply chains, reducing the risk of delays and disruptions. For example, a case study by IBM illustrated how a manufacturing plant reduced its unplanned downtime by 50% and increased production capacity by 20% through the implementation of AI-driven predictive maintenance. In addition to improving operational efficiency, predictive maintenance also contributes to sustainability. By optimizing maintenance activities and reducing equipment failures, companies can lower their energy consumption and reduce waste. A report by the World Economic Forum highlighted that predictive maintenance could reduce global emissions by up to 2.9 gigatons of CO2 by 2030, primarily by improving the efficiency of industrial operations. Despite the numerous benefits, the implementation of predictive maintenance faces several challenges. One of the primary challenges is the integration of AI and IoT technologies with existing systems. Many companies operate with legacy systems that may not be compatible with modern AI and IoT solutions. Overcoming this challenge requires significant investment in upgrading infrastructure and training personnel to work with new technologies. Additionally, the accuracy of predictive maintenance models depends on the quality and quantity of data collected. Incomplete or inaccurate data can lead to incorrect predictions, which can result in costly maintenance errors. Furthermore, the success of predictive maintenance relies heavily on the collaboration between different departments within an organization. For example, the IT department must work closely with maintenance and operations teams to ensure that data is collected, analyzed, and acted upon effectively. This collaboration can be challenging, particularly in large organizations with siloed departments. To address these challenges, companies can adopt a phased approach to implementing predictive maintenance. This approach involves starting with pilot projects to demonstrate the benefits and feasibility of predictive maintenance before scaling up to full implementation. For example, a company might begin by implementing predictive maintenance on a single piece of critical equipment and then expand to other assets as the benefits become clear. In conclusion, predictive maintenance and operations, powered by AI, represent a transformative approach to managing equipment and processes in supply chains. By leveraging machine learning, IoT, and big data analytics, predictive maintenance can predict equipment failures, optimize maintenance schedules, and reduce operational downtime. This approach not only improves efficiency and reduces costs, but also contributes to sustainability and more reliable supply chains. However, the successful implementation of predictive maintenance requires overcoming challenges related to technology integration, data quality, and organizational collaboration. By adopting a phased approach and fostering collaboration between departments, companies can unlock the full potential of predictive maintenance and drive significant improvements in their operations. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.